Hello and welcome to my video called Types of Systems. And just a reminder that this is a very brief summary of what we talk about in class. So it's not really a substitution for what's in class. Make sure you take a look at the slides as well. But types of systems, we're looking at closed, open, and isolated systems. And what's the difference between them? So an open system, we're going to look at first here. An open system means that it shares with the environment, and it shares both energy and matter. With the environment or surroundings. Okay, so an open system shares with the environment energy and matter. So you can think about an open fire pit, right? You put rocks around in a fire, right? Got your rocks around. It's an open fire pit with a log and another log. Beautiful drawing. Look at this. Incredible. You guys are all amazed. Okay, look at this. Look at this fire. Incredible. Oh, I'm going to add some yellow in here. My highlighter. Ooh, fire. Okay, so we have an open fire pit, and you can imagine that the smoke is leaving, which is matter, right? Because there's carbon dioxide in there, there's water vapor steam in there, there's probably just straight up carbon leaving. So carbon dioxide, water vapor is all probably leaving back and forth. There's also heat radiating out. So heat is leaving, right? This is an open system. This whole fire is an open system because it shares heat, energy, okay, and it shares matter, like the gases. Okay, what about a closed system? So a closed system is different. Closed system shares energy, but not matter. Okay, with the surroundings. So a good example of this would be, I don't know how many of you guys use this, but pressure cookers or, Instapots. Instapots, that's the brand name version. Instapot, right? It looks like a pot, right? But then you put a lid on it, and this lid seals it in super well. I'm going to just say Instapot. Okay? Then you can imagine if you're boiling rice, okay, you have some water in here, and you have your rice kernels, which are going to be 100% orange in this case. Okay, so we have our rice kernels. It's not sharing the rice, and it's not sharing the water with the environment. Nothing leaves in here. However, it is sharing energy, right? It's on a hot plate, or it's on the stove top, right? So it is sharing energy. It's getting energy, but it's also losing energy, right? It's losing energy out here, it's losing energy here, and it's gaining energy there. All right, so this is sharing. This is a closed system. Okay, and last but not least, we have isolated, which doesn't share. And it doesn't share anything. It's a bad boy. So isolated systems don't like to share anything, whether that be energy or matter. They don't share anything at all. Isolated systems don't exist. Okay? However, we can approximate an isolated system we can say that there are things that are close to isolated systems. They're not exactly right, but they're close. And one example of this would be if you have a thermos. So a thermos works something like this, where you have probably some sort of air pocket in here as well. So you have a vacuum inside this part, and basically the purpose here is that the vacuum prevents heat transfer. Hopefully you also have an insulated lid of some sort, insulated lid as well. And so your hot soup or coffee or whatever this is inside here, the actual soup is not going to spill, the actual coffee is not going to spill, and the heat ideally doesn't leave. But as we all know, it still does leave. If you wait long enough, even a good thermos will lose its heat. So it's approximately isolated. It's not exactly, because nothing is exactly, but it can be approximately an isolated system. First law of thermodynamics: energy cannot be created or destroyed, only transferred or converted. So with that in mind, we know that energy will always kind of transfer, but we can never create or destroy it, which also means nothing is 100% efficient. Okay, nothing is 100% efficient. AC, fridges, cars, nothing. Okay, and we can use that to our advantage. We can use the idea that heat naturally flows from hot to cold to our advantage, because we can do work with that, and we can actually make engines with that. So if you haven't yet, make sure to watch some of the other videos. Some of them are linked on the slides, but the Watt engine is especially important. So make sure, if you haven't looked at this one, make sure you watch the video for that one. I also recommend the Smarter Everyday video on a see-through engine. That one's really cool as well. So you can kind of understand what a car engine kind of looks like, or a lawnmower engine looks like, what a piston actually is doing. All right, I hope this video helps you understand systems and thermodynamics a little bit better. Good luck.